Hey all, today we are going to continue talking about polygons, and this time we're going to talk about a special type of polygon, which is called a regular polygon. So might not sound special when we call it regular, but it is. A regular polygon is a polygon where all the angles are equal. I'll say all the angles are congruent, and as well, all the sides are congruent. So if I look at this first polygon, this is a six-sided polygon. We call it a hexagon. And it looks like all the sides are the same size. So just like we did back with triangles, we can mark them up. All those sides will be the same, and all of these angles will be the same as each other. So this is a regular hexagon. The regular polygons are the ones that we're typically used to seeing. You know, like a regular octagon is a stop sign, a regular pentagon. Those are the ones that we're used to seeing. So when we see something like this, we can tell right away that the sides are not all the same. The angles are certainly not all the same, and so we would say this is not regular. Again, I'm just going through a couple here to show you the difference. This one, you can tell the sides are not all the same. The angles are not all the same. Some of the angles are bigger than the other ones. For example, this angle is definitely not the same as that angle. And so this is also not regular, but this one is. There is our regular octagon, eight-sided shape. Looks like a stop sign. That's the shape of a stop sign, a regular octagon. So regular polygons, again, have all the angles in the polygon are the same, and all the sides will be the same. And the one other thing that is true about the angles is that the exterior angles will all be the same. So we can have exterior angles at all of these vertices. And as you can see, even though I'm not drawing these perfectly, it should look like all of these exterior angles, if we measured them, would be the same or congruent. And so what we end up with is some relationships. So we did have some relationships last time. We said that the sum of the interior angles was equal to 180 times the number of sides minus 2. And we said that the sum of the exterior angles is always 360. And so when we know all the angles are going to be the same size, we can use this interior angle sum to find one angle. So when we have a regular polygon, one interior angle is going to be the sum of the angles divided by the number of angles. N is the number of angles, which is the number of sides. They are the same in every polygon. And so what this breaks down to be is 180 times n minus 2 over n. The mistake people make a lot is they divide by 2, but we're dividing by n the number of sides. And so if we look here, I have 1, 2, 3, 4, 5. This is an 11-sided polygon. It's a regular polygon. So we can plug 11 in for n into our formula, and we can find the measure of one interior angle. Oops. And again, be careful, we're plugging 11 in twice. So let me calculate. So we get one interior angle to be 147.27. We can also find the measure of one exterior angle here. We know that they should all add up to 360, so, and they should all be equal. So my OEA, my one exterior angle, is going to be the sum of my exterior angles divided by the number of angles there are. Well, our sum is always 360, so this ends up being 360 divided by the number of angles. So that's pretty simple. We're just going to do 360 divided by 11. And we'll get 32.73. And I should put degrees on both of these. And you might notice, you might not notice, it's okay if you don't, that these two angles add up to 180. And so that tells us a relationship between the interior and exterior angles on a polygon. In any polygon, the interior angle and the exterior angle at the same vertex will be supplementary, add to 180. So if you know one of these answers, you can find the other one, or you can just use the two relationships. So let me do another example. I want to find one interior angle and one exterior angle in this polygon. So I need to know how many sides it has. It has 12. So n equals 12. So if I want to find one interior angle, I can use my formula that I'll write every time so that I remember it. I'll remember to divide by n, not 2. That's the most common mistake. And so I'll plug in 12 here twice. And I'm going to pause and calculate this. So we'd get one interior angle in this regular dodecagon to be 150 degrees. And so we could find the measure of one exterior angle by doing 360 divided by 12, or an alternate way to find that is to do 180 minus my one interior angle. So I could do 180 minus 150 and get 30 degrees. If you were to divide 360 by 12, you would also get 30 degrees. So two different ways to find an exterior angle. I actually think finding an exterior angle is easier. So if you find the exterior angle first, you could then subtract from 180 to get the interior angle. So maybe I'll show an example of that here. I have a pentagon, a regular pentagon. It's got 5 sides. And so let's find the measure of one exterior angle. It's going to be 360 divided by n. So in this case, for our regular pentagon, it's going to be 360 divided by 5, which is 72. So we could, to find one interior angle, we could go ahead and use that formula 180 times n minus 2 divided by n, and that will work every time. The other thing we could do is just do 180 minus our exterior angle. So we could do 180 minus 72, and we will get 108 degrees. And if we did the original formula, 180 times n minus 2 divided by n, we would also get 108 degrees. So I haven't showed that yet here, but let me show you. If I were to have drawn that perfectly straight, this angle is 72. This one is 108. As you can see, they make a linear pair because they form a line. They share a side. Those two angles should always add to 180, and that's how it's going to be every time that we have an interior and an exterior angle at the same vertex. So we know this is a regular quadrilateral, better known as a square. We don't have to go through the calculations here. We know all of these are 90. All the interior angles are 90. That makes all the exterior angles 90. So I have 5 of these for you. For each of them, I'm going to ask you to find how big one interior angle is and how big one exterior angle is. So get used to one procedure and go with it. So make sure you stick around and you answer these questions. And if you do have questions, make sure you raise your hand and ask me for help. Make sure you write the formula every time. That's how you remember it. And good luck.